Okay, so let's go to the next question. What is given here? A particle moves, okay, a particle moves along a straight line with retardation. Okay, it is given, it is not acceleration. Remember, in this case, it is given retardation. Very important point. Okay, it is retardation. Retardation means what will happen? In the retardation, always remember a speed of the particle will decrease. Okay, in the retardation, a speed of the particle will decrease. Remember, I am not saying velocity. Okay, in the retardation case, remember acceleration and velocity must be opposite to each other. Okay, so only a speed will decrease. What about velocity? It may increase or may decrease. So particle moves along a straight line with retardation proportional to its displacement. What we can say? Proportional to its displacement. Its loss, okay, its loss in kinetic energy for any displacement x is proportional to. They had asked about, okay, ki for any displacement x, okay, the loss in kinetic energy will be how much? So again, look, it is simple. Loss in kinetic energy. When in the mind they have asked something like that one, loss in kinetic energy. So what we can do? Directly work energy theorem should come in mind, because we know work done by all the forces equals to what? Change in kinetic energy. And change in kinetic energy, what we can say? It is just negative of loss in kinetic. Look, loss means what we can say? Loss means it is final minus initial. If you will write loss in kinetic means k final minus k initial. Okay, this value should be negative. Why negative? Because it is loss. There will be loss of kinetic energy. K final minus k initial, what we can say? Here if you will write k final, so delta k in this case, what it is going to become? It is going to become negative. Okay, so rather than writing positive, we have to write negative itself. Why? Because it is loss, we can say. So final speed, okay, definitely it is going to be less than initial speed. That's why it is given what? It is retardation. So they have asked, okay, what we can say? So here if I want to write work energy theorem, okay, so work energy theorem equals to what we can say? It will be equals to loss in kinetic energy. That we know, work done by all the forces will be equals to how much? Delta k. And delta k, because it is a loss, we can say. So let's calculate. Okay, first what we can say? It is given ki the retardation means acceleration. If we will write, it will be negative. So acceleration I am writing something minus k into x, we can say. Okay, acceleration I am writing something minus, because it is acceleration is directly proportional to x. Negative y I am giving because it is retarding. Okay, it means x, if you will take positive, acceleration will become negative because it is retarding, we can say. So acceleration is retarding, okay, and particle is, okay, it is given for any displacement of x they are asking. So here force, if you will write, it will become how much? Minus of m k into x, we can write. How much it will become? Minus of, because mass into acceleration will give you force here. So look here, what we can say? This force is variable in nature. This force is variable in nature. So what we can say? Work done, if you want to find for this force, we have to perform integration. Why we have to perform integration? Because this force is variable in nature. So here you can write force dot, what we can say? ds, we can say. And as force is only given in the x direction, so we can directly write minus mkx into dx, we can say. Now what we can say? For the displacement of x they have asked. So let's assume that particle has moved from 0 to some, what we can say? It has moved from 0 to x distance. So let's perform m and k. Okay, that is k is proportionality constant we are taking. So minus mk will be outside. Integration of x dx will come how much? X square by 2. It will come limit what? 0 to x, we can say. So how much it is going to become? Minus mk. Okay, 2, let's take it outside because anyway it is constant, and upper limit x square minus 0, we can say. So it will come how much? Minus mk x square by 2 itself, we can say. Now what we got? This one, this is we got work done by all the forces. And from using this work energy theorem, what we can write? Work done by all the forces. That is how much we calculated. That is we calculated w. So we can write this is minus mk x square by 2, that is equals to change in kinetic energy. Change in kinetic energy means delta k, we can write. Okay, that is delta k. So they have not asked change in kinetic energy, they have asked loss in kinetic energy. Means what we can say? Minus of delta k. This will be what we can say? It is, we can say, if you want, it is loss in kinetic energy, we can say. Delta K is nothing but it is what? Loss in kinetic energy. That will come how much? Mk x square by 2, we can say. Now they haven't asked anything regarding constant. They have asked only up to the loss in kinetic energy for any displacement x is proportional. Proportionality, so what we can say here, minus delta K will be directly proportional to x square, we can say. So here what we can say, your option C will be the correct one. Option C will be the correct one. So let's using this one, what we got this loss in kinetic energy using the work energy theorem itself. So let's move to the next question. So what it is given in this one, the upper half. Look, this question has been I have taken from the earlier JEE means question. At that time it was known with the name of AI triple E. This question has been asked in the previous exam itself. It is given the upper half of an inclined plane with inclination phi. With inclination what is given? Phi is perfectly smooth is given, while the lower half. So if I am drawing the inclined plane, just think about this is the inclined plane. I am drawing here. Just 1 second. So this is not correct. So this is given inclined plane where angle of inclination is given how much? Phi. So assume that total angle of inclination was for a moment it is given S. What I am assuming, total angle of total the inclination distance I am assuming, that is S. Angle of inclination is already given. This is not given. We have assumed. In the last we have to eliminate this S itself because this information is not given. So remember, in any question what the thing you are assuming, in the last you have to, what we have to do, you have to remove that assumption from your final answer, we can say. So total it is given the upper half of this inclination is given a smooth, means here to suppose this is given S by 2. This is given S by 2. So this is part is given what? This part is a smooth given. It is given a smooth, and lower half is given rough. It is given rough part. The lower half is given. You can see here it is given what? Rough itself. A body. A body is starting from the rest. Means suppose some body I place here. If you want I can take some other color also. So this body is placed what? At the top one. It is placed at the top one. Remember this half part. If you want to say this half part is a smooth, it is given. It is given a smooth. And lower part is given a rough one. So starting from here what we can say, V initial is, we can say it is 0. Starting from rest at top will again come to rest. Starting from here rest and V final again it is becoming what we can say, it is again becoming 0. After again when block has arrived here, this final velocity again it become what? 0. So as surface was smooth, definitely here a speed will increase. A speed will increase up to this point. What will happen? A speed will increase. After that this surface what it become? It become rough. This surface become rough. So result of that what we can say, here a speed will start decreasing. Maybe friction will be more than the component of mg along the inclined plane. So result of that what we can say, body will start retarding. So if the coefficient, so what they have asked, rest at the bottom if the coefficient of friction at the lower half is given by, so how much the friction of coefficient will be at the lower half, you can say. So just I am taking one more inclined plane to show you every forces which is acting on the body itself, you can say. So look here what we can say, the first half distance. So here in general if I place any body along the inclined plane, this inclination is given phi. So perpendicular to inclined plane if you will take here, so this will be vertical down along this one, mg will act. This angle, this angle is given phi. By mistake I have taken. So this angle, just 1 second, yes, this angle is given phi. So this angle will also become what? Phi. In the Newton's law you would have studied about this one will become normal force. So along this perpendicular to inclined plane, this is I am taking one axis which is perpendicular to what we can say, it is inclined plane. So along this direction component will come how much? Mg cos theta, cos phi it will come, and along the inclined plane how much this okay component of weight force it will come, that will come mg sin phi. Okay, it will come mg sin phi. Now what we can say, friction will act, okay, this friction will act opposite to this motion, opposite to relative motion, because this block is going down, so friction will act in the upward direction, not in the first half. Remember, I am just for the diagram purpose I am showing here, not in the first half, but it will start acting in the second half. We can, that friction force will become how much, okay, already know, mu into n we can say. So here there is no motion is happening perpendicular to inclined plane, so normal will become equals to how much, mg cos phi we can say. It will come how much, mg cos phi. So this friction force if I will write, okay, friction force how much it will come, mu into n, and that will come, mu is I am taking coefficient of friction, and normal will come how much, mg cos phi we can say. Okay, mg cos phi. So rather than looking this whole motion in two part, what we are going to do, we are going to utilize work energy theorem, and we will observe whole motion in the single observation, whole motion in single observation itself. So throughout the motion, okay, you can see here throughout the motion, okay, mg sin theta will be always down the inclined plane we can say. Okay, mg sin theta will be always down this mg sin phi, okay, not phi theta, this mg sin phi will be always down the inclined plane, but this friction force will only act in the latter half of the inclined plane. This friction force which will be up the inclined plane, it will act only latter half of the, what we can say, motion itself. So let's start the discussion. Whole motion I am looking in the single instant itself. So how many force will do the work on this block? Okay, normal, this normal and mg cos theta both will be perpendicular to the motion of the block. Motion is happening along the inclined plane, remember. Okay, motion if I will say, so what we can say, just one second. Okay, motion if you will see here, okay, motion is happening along the inclined plane, but this normal is, what we can say, normal and mg cos theta are perpendicular to inclined plane. So work done by normal and mg cos theta will become what, 0, because angle between force and displacement is 0 we can say. Okay, but what we can say, that will be not the case in case of mg sin theta and friction we can say. So let's calculate first work done by, what we can say, work done by mg sin theta. Okay, mg sin theta. So force is constant, remember mg sin theta is, oh sorry, mg sin phi we can say, mg sin phi is constant. So here mg sin phi is acting, mg sin phi is acting down the inclined plane, and displacement also happen, that is I have assumed is also down the inclined plane. So work done will come how much, mg sin phi into s we can say. Remember why I have written this one, because both displacement and force are in the same direction. Next, if I am calculating work done by friction force, remember friction is only acting in the lower half of the motion, not whole motion, only lower half. Lower half means later s by 2 distance we can say. So in this case what we can say, friction is acting up the inclined plane. Friction is acting what, up the inclined plane, but block is moving down the inclined plane. So angle between friction force and displacement, how much it will come, it will become 180 degrees. So work done, what we can say here, if you will write, so it will come friction force into displacement is how much only, s by 2, and angle will come cos 180 degree. Why 180 degree? Because both displacement and friction force are opposite to each other. So here what we can say, friction force already we have calculated. Here you can see this friction force, how much we can say, that is mu friction coefficient mg cos phi into distance, okay, displacement is s by 2 into minus 1 we can say. So this value will come how much, minus mu mg, okay, s into cos phi we can say by 2 we can say. So this friction force, remember work done by friction force become negative. Other force if you write work done by, remember, okay, work done by normal force and work done by mg cos theta, okay, it will come, both will come what, 0. Why it will come 0? Because force and displacement are perpendicular to each other. So we can use work energy theorem, work done by sum of work done by all the forces equals to change in kinetic energy we can say. So use 1 by 1 work done by mg sin theta. Okay, so that is how much we can say work. Let me write 1 by 1 work done by mg sin, okay, sin phi, okay, plus work done by what we can say friction force, plus work done by normal force, plus work done by what we can say here you can write mg cos phi, all should be equals to how much change in kinetic, means k final minus k initial we can say. So if you for your further reference what we can say this final kinetic energy, final speed is 0 as well as initial speed is 0. So what we can say here final kinetic energy is going to become 0 as well as initial kinetic energy is also going to become 0. So let's substitute that one all the things one by one. So mg sin phi, okay, so work done by this one will come how much, okay, mg, okay, sin phi, okay, into s plus work done, okay, work done this one is negative, so minus mu mg, okay, mu mg s into cos phi by 2 and all the other thing will become 0, should be equals to 0 itself. So let's what we can do, okay, here a space is not sufficient, so what I'm doing, I'm erasing the top part. Okay, if any person have any doubt you can go back in the video. So this one part I'm just erasing that one, okay, so that I can write this one here. So this here if I will simplify here, so what we can say this negative part I am taking other side, so it will come mg, okay, sin phi into s equals to how much will come mu mg cos phi into s by 2 we can say. So from here mg will cancel out s and this is, so remember what the assumption is I have taken in the beginning, finally it is getting cancelled out we can say. So what we can say here, okay, if I want to write that one, so from here we are interested in this coefficient of friction, so let's write what we can say after doing cross, mu will become how much, 2 will go other side, cross multiplication sin phi, cos phi will go in the denominator, this cos phi will go here in the denominator, so it will come sin phi, okay, by cos phi we can say, and that will give you how much, 2 tan phi. So this will be your answer, so this will be your answer. So today video I will stop here, okay, again in the next class I will come with some interesting topic. Okay, so if any person have any doubt please write down there in the comment box, and don't forget to like, share and subscribe my channel and press the bell icon for any future video. Thank you very much.